So, hi everyone. Today we will be talking about Meta's Coconut, a better alternative for chain of thoughts for LLM reasoning. So, this was one of the most important papers that was released last month. I was not able to cover it because of some reason, but it's better late than never. So, this is one of the new paradigm that the Meta team has introduced for LLM reasoning. So, I assume that you might have heard of concepts like chain of thought, React agents, and trees of thought concept where we are trying to make the LLM to reason before giving an answer and hence improving its output. Now, Meta's Coconut is an extension. You can take it as an extension chain of thought, that is chain of continuous thought. So rather than reasoning in text level, it is reasoning at a continuous latent space. I will be telling you what does this mean. So first of all, let's try to understand the problem with language based reasoning, chain of thoughts or react or trees of thought. So basically this reasoning happens at a text level. They are outputting their thoughts, they are writing it. It is done at a token level. So, what are the issues? Inefficiency. Many tokens in the reasoning chain are generated for textual coherence rather than actual reasoning, that leading to wasted computational resources. So, for example, if you remember O1 when it came, it used to take a long time and then it used to output because it was using some concept like this, which was outputting a lot of tokens and leading to wastage of a lot of tokens because you are trying to write down every thought. Just think of it. You would think of an idea. If you start writing everything, you will take more time. Complex planning. Some critical reasoning steps require complex planning, which is challenging for LLMs when constrained to language space. Certain thoughts you can't just pen down. Just think of it. Think of it as a human being. When you start penning down, the way you think about it might change a bit. So this is what they're talking about. Certain complex things just can't be written down in language space. Human cognition comparison. So one comparison with chain of thoughts, one limitation it has is that it is not similar to human reasoning. That what I was coming to, that it relies heavily on language. Human doesn't think in language. They doesn't write everything. We think in our head and then whatever comes to our mind, the final answer we output. So this is not similar to human thoughts. What if the reasoning can be done in background of LLMs? They can, in their back mind, they can think and then come out with an answer. Coconut stands for that, reasoning in latent space. So by latent space, we mean that take it as a back mind of LLM. It won't be right because it's not a human being, but for now we can assume that. So core idea is that instead of decoding the hidden states of the LLMs into word tokens, so rather than outputting the word tokens, Coconut uses the last hidden state called as continuous thought as an input embedding for the next state. Makes sense? So when an LLM is outputting some text, the layer before that, which is the hidden state, that is getting used rather than the output it has generated for the next idea. This allows the model to reason in a continuous latent space, free from constraint of natural language. So what happens if I give you a brief? Just try to imagine this. You think the LLM thought of an idea, it penned it down. Now for the next idea, it will intake the previous idea, convert it back into embeddings, and then use it for generating the next idea. Here you can see that there is some lag. You are generating tokens for nothing. So what it does, Coconut intakes embeddings directly rather than taking the output tokens. That's the modification. The model switches between language mode, generating tokens, and latent mode using continuous thought. Special tokens and mark the beginning and end of the latent reasonings. Now, what are the advantages? Efficiency for sure. Continuous thoughts can encode multiple potential next steps, right? Enabling breadth first search. Continuous thoughts are fully differentiable, allowing the system to be optimized end to end. Right. So these are the advantages that we get, and the results have improved also, as the team has mentioned in the results. Training and inferencing. The training strategy for training an LLM with continuous chain of thoughts, that is Coconut, it is a multi-stage training curriculum inspired by implicit chain of thought. In the initial stages, the model is trained on traditional COT data, that is chain of thoughts. As the training progresses, language reasoning steps are gradually replaced by continuous thought. So we start off with chain of thoughts, and as you move ahead in the epochs, what you will do, you will slightly change the reasoning part into. So it's not all over Coconut. You would first starting off with chain of thoughts only, and then gradually will moving on to continuous thoughts. Right. During inferencing, the model alternates between generating tokens in language mode and reasoning in latent mode. So it's switching between language and latent. So language mode would be coming out when you're giving a final answer, while the reasoning part won't be shown to you, but that would be done in your latent. So by now, if you haven't understood the difference between, say, chain of thought, it's one of the language-based reasoning, and coconut, let's have an example. Assume that this is the prompt you're inputting. John has 3 apples, he buys 5 more. How many apples does he have now? So in case of chain of thoughts, this would be some steps that the model might take. John has 3 apples, he buys 5, 3 plus 5. So there, it would be going for step by step answering. Now in case of coconut, you won't be seeing these 3 steps. It would be happening, but you won't be seeing it. The reasoning won't be visible to you. The model starts by encoding the question in a continuous thought. Instead of generating words like 3 plus 5 equals to 8, the model performs the reasoning internally. The continuous thought encodes multiple potential next steps: 3 plus 5, 3 minus 5, 3 into 5, whatever it can think of, and then comes out with the final answer. Key differences as mentioned: each step is a token. The reasoning is visible in text. In Coconut, reasoning is in hidden vectors. It's in a latent space. Nothing is visible. Why Coconut is better? I think we already talked about it. For tasks requiring backtracking and complex planning, Coconut can maintain multiple options in latent space. Flexibility: the model can explore multiple reasoning paths because it is doing everything in its head. It's not writing down it, right? And efficiency: it avoids generating unnecessary tokens. So recently, I think Meta team has also released the GitHub repo for training LLMs using Coconut. Let me show you that. So this is the repo that has been released by the team of Meta, Coconut, where all the codes are present. You can now train your LLMs using the Coconut approach, and let's test out how good the models are. They have provided all the steps how to do it, how to install, how to prepare your training data set. So I hope you try out running Coconut, and this is the particular GitHub URL, Facebook Research Coconut. I hope you like this particular tutorial and you understand what is Meta's Coconut. Thank you so much.